Hey everybody, we're going to go over the 4.3 notes today. This should also be available on Classroom, so you can look up all of the individual pieces of the notes later if I end up moving too fast. Okay. We're going to be learning about interval notation of inequalities. Interval notation is really similar to when we did domain and range a while back, and inequalities just means you're going to have to solve inequalities like we did this last week or so. Let's start by doing the definition of interval notation. Interval notation uses brackets and parentheses to describe the domain, because what we're talking about is whether x is greater than or equal to a number, if x is less than a number, and remember that domain is all of the possible x values that we're going to get. We have to know what arrows we're going to have when we have what kind of infinity signs, or if we have a left arrow on our graph or a right arrow on our graph. Are we going to use infinities? Are we going to use brackets, parentheses? What are we going to do? So back when we did domain, whenever we had an infinity sign, we used a parentheses. And the negative infinity had to be first. This means that anytime you have a left arrow on your graph, you're going to be using a left parenthesis and a negative infinity. Okay, then you're going to have a comma, and then you're going to have something else, and we don't know what it is, and we don't know what the other bracket's going to be. So it just depends on what the number is for this endpoint right here. For positive infinity, that always happens on the right side of the graph for domain. So we're going to be using a positive infinity and again a parenthesis, and then we're going to have that right arrow. For inequalities, we are going to replace a less than or a greater than symbol with a parentheses. Remember when we have these and we are graphing, we use an open circle? Well, a parenthesis is really similar to an open circle. So whenever you would use an open circle, you're going to use parentheses. Less than signs that have an equal to or greater than or equal to signs, those guys are going to get brackets. How I always think about these is you've got this extra special little line here, so that extra line makes a really sharp bracket like this, sharp brackets. Parentheses happen for open circles, which if you put two parentheses together, they almost look like an open circle anyway. Example 1, we're going to practice graphing and writing interval notation. We've already done a bunch of graphing, so let's get right to it. X is greater than or equal to -2. You put your -2 and 0 on your number line. We're going to use a closed circle because this has an equals line, so closed circle here. And then because X is first, we are going to shade in the direction that this arrow points, which is towards the right. This means that x can be any big numbers. It cannot be anything that is less than -2. So that means that the least value, the smallest that x can be is -2. Then the biggest x can be is positive infinity. Just like when we did domain back with our graphs of whole equations, right? We had arrows, if they point towards the right, you're going to have a positive infinity because these are the positive x values. And the numbers in your domain have to go from least to greatest. Okay, we're going to put a comma in between, parentheses always when we have an infinity or a negative infinity. And then since this is a equal, we have a closed circle and we have a bracket. Equals, closed circle, bracket all go together. All right. Let's zoom in on example number 2. We've got x is less than 4. So we've got 0 and 4 on our number line. This is going to be an open circle because there's no equals. And with x first, we're going to be shading in the direction that this arrow points. Looks like the arrow is pointing towards the left. And it is also known as a less than sign. Less than points towards the left. So x can be any number that is smaller than 4. When we have left arrows, that means that x can be anything all the way down towards negative infinity. So we're going to put in negative infinity first. And then x can be anything in this shaded region all the way up until we get to the number 4. That's where our end point is, so we're going to use that number again. Infinities always get a parenthesis. And then our endpoint 4 needs a parenthesis as well. There's no equals, gets open and open here with a parenthesis, because 4 cannot actually be a value that we plug in here for x. So open says we're not allowed to do that, and parentheses say we're not allowed to use that number either. Okay. On example 3, we actually have to solve this guy out. So we're going to distribute the 3. Sorry for the shaky cam, guys. This is the best I can do. We got 9x plus 21 is greater than 84. Subtract 21 on both sides. We get 9x is greater than 63, which means that x is greater than 7 when we divide both sides by 9. Based on the fact that there is no equal sign, we know we're going to use an open circle. X is the first thing in this inequality, so we're going to graph in the direction of this arrow. It is pointing towards the right, so we're going to graph right. Okay. This means that it's pointing towards positive infinity. So the lowest thing that x is allowed to be, it's not actually allowed to be 7, but that's our endpoint. The least number is 7, and the greatest thing is infinity. Infinity always gets a parenthesis, and if you have an open circle, you're also going to have a parenthesis. Okay, if I'm working too fast for you to keep up, it is still available on Google Classroom. All right, practicing writing compound inequalities in interval notation. So compound inequalities were the problems where there was an and or an or. When we have and problems, we are generally going to be shading between two values, right? We end up with answers that look something like the barbell, something like this. They might be closed circles, they might be opened. It depends on whether your inequalities have the equals bar underneath. Okay, but you're going to be shading between. So that means that your x values for your domain are going to be between two numbers. So you're going to have the least number on the left and the greatest number on the right. And then you're going to either use parentheses or brackets based on what your symbols mean. Okay, so they might be brackets instead of parentheses. This is just an example. Okay. When you write or problems, we are shading to the left and to the right. Okay, that's the general idea of what's going to happen for an or problem. So like we can see, we've got starting at negative infinity because we have a left arrow. We have a number, so we're going to have a circle, either open or closed. So it's going to be that number. And then this little U here stands for the word union, which means both. Okay, we've got to put that U. It's not really a capital U, but it kind of looks like one. It doesn't have like the little tail end over here. Okay, so it almost looks like a capital U. All right, we've got a number and then infinity. Okay, so we've got an endpoint and we've got the arrow pointing off to the right-hand side. Okay, so these are the general domains, also called interval notation, that we are going to get when we have compound inequalities. All right, let's move down and work out these 3 examples down here at the bottom. Example 4 is already worked out for us. I've got negative 3, 0, and 2 on the number line. X is less than negative 3 or x is greater than or equal to 2. X is first in both of these inequalities, right? Separated into 2. Or problems, we should be shading to the left and shading to the right. So negative 3 looks like it's shading to the left. And it is an open circle because we don't have an equal sign. 2 has an equal sign, so we're going to fill in the circle, making it a closed circle. And since x is first and the arrow points right, we're going to shade right. So our interval looks like it's pointing in 2 different directions with a gap here in the middle. So that means we should have a gap when we write our interval notation. So the very least thing that we can have is negative infinity. And this goes all the way until we get to this number, which is negative 3. -3 is going to get a parenthesis because we have an open circle. Infinities always get parentheses. Now, since we have another shaded region over here, we're going to have to use that weird U for union. Okay, then we start up again at 2 and we go all the way to positive infinity. Remember that we read these graphs from left to right, meaning least to greatest. So we always have to start with what's on the left. You can't do this one first. Infinity always gets a parenthesis. 2 is filled in. It's a closed circle. It also has an equals bar, so we're going to use a bracket. That's example 4. On over to example 5. We've got x is less than 4 and x is greater than or equal to -1. Okay, so the way that we graphed these before, we had x is less than 4, so open circle, shade to the left. And for -1, we're going to have a closed circle, shade to the right. But the issue with and is we are looking just for the overlapping portion. Okay, and that overlapping portion happens from here to here. Okay, so it's this middle part. So when we draw that little barbell for the overlap, we're going to have from -1 to 4. So the blue part that I've got up here, that's the only part that's in our domain because we have to make both of these inequalities true. So the numbers between -1 and 4 are the ones that make this true. Since it's going between two numbers, we're only going to use one interval. Okay, this word and up here, one interval. So we're going to have least number, comma, greatest number. So our interval here is -1 to 4, -1, comma, 4. And then the -1 is the one that has the equals and the closed circle, it gets a bracket. So we close it up with a bracket. 4 does not have an equals. It's an open circle. It gets a parenthesis. All right, on to example 6, last thing. We've got two inequalities that we need to solve. First guy, I'm going to divide by -9. Now that's that one weird rule with inequalities is that when you divide by negative numbers, of course, or multiply by negative numbers, you have to switch the inequality sign. So this inequality symbol is going to face towards the right instead of the left. So from -3, we're going to have an open circle, shading right. And on this guy, we're going to add 7 to both sides. So we get x is less than -7. -14 plus 7 is -7. It's open circle again, and shading left this time. Left because arrow points left. This is an OR problem. We should expect the graph to go in two different directions, which means we're going to do two intervals. Least is -infinity, comma, where does this little part stop? At -7. Parentheses for all infinities. -7 has an open circle, so open it with a parenthesis. Going to have two intervals, so we use the U for union. Then the next number that we have is a -3, and then it's going to go towards positive infinity. So 3 to infinity. Infinities always get parentheses. The -3 is no equals. It's an open circle, so opened with a parentheses. All right, I'm also going to post this up on Google Classroom so that you guys have access to it. Remember to do the homework on the back. Right, we've got 6 problems back here. The top 3 of them you solve and graph. Bottom 3 we have ands and ors, so make sure you use those compound inequalities like we just did, and then turn that paper into the top box of my big blue turn-in bin when you are done. Have a great rest of your day, guys.